There are many different views or VR device classifications. VR devices can be classified mainly according to the mobility. There are mobile VR devices. These devices do not need to connect to a personal computer. All the calculations and graphical operations are performed within a virtual reality device. It is easy to transport them. On the other hand, they are weak. They are 100 times weaker than PC-based virtual reality and cannot recreate such realistic virtual reality scenes. On the other hand, PC-based or wired solutions can provide the best virtual reality possible, but it is harder to transport and set them up. This is not only classification of VR devices. VR devices can be classified according to the technical features such as tracking technology, input methods, and other. The first real mobile virtual reality was introduced by Samsung company, which released the Samsung Gear VR device. The smartphone served as a computing device and a screen, while Gear VR device provided rotation tracking capabilities. Later the two devices merged into one. Computing, visualization, and tracking capabilities were integrated into one device. Typically, such VR devices have significantly lower technical parameters and limited technical capabilities. They cannot recreate such realistic scenes as PC-based virtual reality. On the other hand, it is easy to use and transport them. Wired solutions require a PC connected to a virtual reality headset. It has many advantages, with computational power being the major one. The computing power of a personal computer can be over 100 times higher in comparison to mobile devices. Therefore, a computer can recreate photorealistic and complex environments. The downside is that the transportation of a whole VR system, including a computer, is more difficult. Also, such a system may cost up to 10 times more than a mobile system. Now we'll take a look at the devices that are or were on the market. The list that you see here includes both mobile and wired systems. I will discuss these VR devices in detail. Let's start with historical smartphone-based devices such as Cardboard, Daydream, and Samsung Gear VR. Not many of these devices are available nowadays, but it is important to know about them. The smartphone is required for all of these devices. They support 3 degrees of freedom tracking, which means they support tracking the rotation of the head. The operation depends on the technical capabilities of a smartphone. Cheaper devices may have misaligned optics, which results in reduced user experience. The most popular device nowadays is Cardboard because it is very cheap and affordable. On the other hand, such device cannot offer the real virtual reality, and its use may affect the health of the user. Avoid using Cardboard for virtual reality experiences. Samsung Gear VR is the first smartphone-based virtual reality device that provides real virtual reality because it includes sensors for smooth head rotation tracking. Only Samsung Galaxy S and Galaxy A phone models can be used with this device. A motion controller could be used for input, not widely available nowadays. Oculus Go, Daydream Standalone, and HTC Vive Focus were the first standalone virtual reality devices that did not require smartphone usage. All these devices provide a high-resolution view. Motion controllers could be used for input. Oculus Go provides 3 degrees of freedom, while other devices provide 6 degrees of freedom or a free movement. These devices also are not widely available today. Oculus Quest was the first standalone virtual reality device that provided 6 degrees of freedom as well as precise tracking of VR controllers. This feature, along with its affordable price, influenced the widespread use of this device. After Facebook acquired Oculus, the Reality Labs division of Facebook developed Oculus 2. Later, this product was rebranded as MetaQuest 2. Acquisition by Facebook further increased the prevalence of this device. This device supports 1832 on 1920 resolution per eye and up to 90 Hz refresh rate. Following the success of Quest 2 device, new companies started to develop similar devices, pushing the limits of the technical capabilities further. The device worth mentioning is a new Pico 4 headset developed by ByteDance company. The Pico 4 uses pancake lenses in combination with 2 small LCD displays, one for each eye, in the head-mounted display. This technology allows for a lighter headset with an increased image resolution. The MetaQuest 2 and Pico 4 are very similar virtual reality headsets. They both have an all-in-one design and use the exact same processor. The Pico 4 gains the edge in the terms of hardware with a lighter and more comfortable design, superior screen resolution, and a larger battery for extended runtime. But Pico can't compete with Meta when it comes to the available VR software. All the mentioned devices, Windows Mixed Reality, Oculus Rift S, and HTC Vive Cosmos, have one thing in common. They all employ inside-out tracking and use a computing power of a personal computer. In other words, these are the wired devices. These devices were developed by corresponding companies, Microsoft, Facebook, and HTC. Nowadays, these devices are not popular due to the fact that autonomous devices such as MetaQuest 2 can be connected to the computer to employ the computing power of a PC if needed. Until the year 2011, we already had solutions that allowed us to see what virtual reality would look like. But none of these solutions was good enough for the market. Oculus started the revolution of VR devices. In 2012, Oculus initiated a Kickstarter campaign to fund the Rift's development. It was successful. The first Oculus Rift prototype is shown on the top right corner. The first consumer version appeared in the year 2015. Oculus Rift uses 6 degrees of freedom outside-in tracking with one sensor. The computer is required as this is the wired solution. On May 2019, Oculus began shipping a new VR headset known as Rift S, which we already talked about. Later in 2021, it was discontinued to focus on the Oculus Quest 2, effectively ending the Rift line. HTC solution, the HTC Vive device, introduced in the year 2015, demonstrated how important is the interactive side of virtual reality. This device introduced room-scale tracking that employed an innovative lighthouse system to track the headset. It uses external base stations to track users' movement in a physical space of up to 5 square meters. The Vive Pro Eye is a more advanced version of Vive with integrated eye tracking technology that allows for more natural interactions in VR and can improve performance by only rendering great detail where the user is looking. Valve Index is a high-end VR headset developed by Valve Corporation. It features a dual-element lens system that delivers a wider field of view and less distortion compared to other VR headsets. It also uses a high-resolution display and a high refresh rate of up to 144 Hz. It also features a unique set of controllers with finger tracking, which allows for more natural and intuitive interactions in VR. PlayStation VR and PlayStation VR 2, developed by Sony, offer a high-quality VR experience with a focus on gaming and entertainment. PlayStation VR, also known as PSVR, is the first-generation VR headset. It uses a single 1080p display that has a refresh rate of up to 120 Hz. The headset is designed to work with PlayStation 4 and PlayStation 5 consoles, and it uses a single camera to track the position of user's head. PlayStation VR 2, also known as PSVR 2, features a high-resolution display and a refresh rate of up to 120 Hz. The headset also uses a new VR controller with advanced haptic feedback for more immersive interactions in VR. The PSVR 2 requires a PlayStation 5 console to operate. Pimax is a virtual reality headsets brand that develops devices known for their wide field of view, which is larger than that of most other virtual reality headsets. The Pimax headsets also have high-resolution displays, 4K for each eye, allowing a wide field of view to be implemented without losing quality. This device supports viewing angles of up to 200 degrees diagonally, 170 degrees horizontally, and 115 degrees vertically. These headsets are compatible with both SteamVR and Oculus platforms. They use SteamVR tracking technology, the same that uses HTC and Valve products, to provide precise and accurate motion tracking. Because of a need to render high-resolution 4K images, this is a wired solution and requires a high-end computer.